Find the volume of the solid obtained by rotating the region bounded by x equals y squared plus 1 and x equals 5. That's going to be rotated about the line x equals 5. Very first step in the process is to draw the graph. The issue that we're going to have is this x equals y squared plus 1. We'd have an easier time if it was y equals x squared plus 1. This would be a parabola, y equals x squared, that's been shifted up 1 unit. So how does it change when the x and y flip? What does x equals y squared look like? It's just a parabola that's on its side. Okay, but what does the plus 1 do? And so the plus 1, we have to figure out, is it a shift to the left? Is it a shift to the right? See what happens when you plug in y equals 0. We'll have x to be 0 plus 1. X should be equal to 1. So if you're going to take a parabola that's on its side, and then when y is 0, x is going to be 1, then that means you must have shifted it over 1 unit. And so we have the graph would then be a parabola shifted 1 unit to the right. Okay, great. Parabola on its side shifted 1 unit to the right. Okay, now we have the line x equals 5. We'll just label this as 5. And we want the region that's bounded by these. So we're talking about this interior region here. And what we're going to revolve that around is the line x equals 5 again. And so we're done with step 1. We figured out exactly what the graph looks like of the region. And now we want to move on to step 2. We want to be able to decide which method to use. And when you're deciding, you should take 2 copies of the graph. One where you draw a rectangle parallel to the axis of rotation, and one where you draw a rectangle perpendicular to the axis of rotation. When your rectangle is perpendicular, that's the shell method. When your rectangle is parallel, that's the shell method. When your rectangle is perpendicular, then that's either disc or washer, based on whether or not you're going to have a gap between your region and your axis. Your axis of rotation, that is. We're rotating about this line, x equals 5, and so the region is flush up against that axis, so that means it's going to be a disc method. When your rectangle is vertical and moved horizontally, then you're in the variable x. When your rectangle is horizontal and moved vertically, then you're in y. Now let's take a look at the shell method and see how far that would go. The formula for shell would be that we need to find the radius and find the height, and then plug into the formula that's above there. Well, how do we find the radius? We take a line that goes from the axis up to that rectangle that we drew. That distance is the radius. Whenever it's removed away from the x or y axis, it becomes a little more difficult. We have to do some kind of subtraction or addition. This distance is the subtraction of 2 distances. One distance subtracted from another. We have this distance here, and from that we need to subtract another distance. How long is that? That's always going to be 5. From that we need to subtract the distance that's off the y-axis. That's called x. So our radius is 5 minus x. The next question is, what's the height? The height is how tall the rectangle is. That's going to be trouble for us because it's this integral is supposed to be done in x. And this distance off the x-axis is called y. But not only do we go upwards from the x-axis, we also go downward. So it turns out that the height is actually twice y. But we don't have y, we have x equals. We can solve it for y. Subtract 1 from both sides, and then take a square root. Technically it's a plus or minus square root, with the upper part of the parabola being the positive square root. The lower part of the parabola is the negative square root. So twice y would be basically adding these two distances together, and so that's how we get the height to be twice the square root of x minus 1. And basically we're going to end up not doing this method. We're going to take a look at disk and find out that disk is going to work much better in this particular example. Okay. Lastly, we can get the limits of integration. There's a low point of x equals 1 and a high point of x equals 5, and so that would be the setup if we wanted to do this in shell. But let's look at disk. The formula for the volume by disk method is for us to find the radius. The radius is how tall the rectangle is. And it's the same kind of idea as we had with shell. It's the subtraction of two distances because it's been moved away from the y-axis. We have this solid distance of 5, and from that we subtract this distance off the y-axis, which is x. But wait a minute. We said that disk was supposed to be in terms of y. And so we need to replace the x with the formula for y. Y squared plus 1. That's our radius. And what we could do is distribute the negative across. By distributing the negative across, that'll be subtracting 1. 5 minus 1 will be a 4. Our radius is 4 minus y squared. Okay. Well, what about the limits? We have some low point here. By the graph, this is an exact computer-generated graph. It looks like minus 2 and 2. But if we were to find it, we have to look at the intersection between, our two functions here. X is y squared plus 1, and x is 5. Set them equal to each other. Subtract the 1 and take the square root. That's how we get the plus or minus 2. So we have the setup for disk formula. That is going to be pi times the integral from negative to the 2 of that radius, 4 minus y squared, quantity squared. And this is going to be an easier integral to do than one that we would get by multiplying these two guys together using shell. So let's go to the third step in the process. Let's go perform the calculation. Let's square out 4 minus y squared. Yes, we do get the 16. And yes, we do get the y to the 4th. But you can't be short-sighted and think that you can just square each one of these. There's a middle term that you'll be forgetting about. A minus 4y squared and another minus 4y squared to give you minus 8y squared. Okay. Now something should jump out at you. The limits of integration were minus 2 and 2. Negative 2 and 2. Whenever you see limits of integration of negative a and a, you should stop for a second and think about the function that you're integrating. If this function that you're integrating is either even or odd, your integration can be simplified. It turns out that this function is an even function. When you have a polynomial, it's going to be even if all the powers are even, and there's a possibility that a constant can be there too. And so this is an even function. What does that mean? Well, when you take an even function and integrate it from minus a to a, you can then instead just focus on the right hand side, integrate from 0 to a, and double. Even means symmetric with respect to the y-axis, and so that you could do that. And we'd much rather have 0 as a lower limit than negative 2. Don't forget the double though. Alright, antiderivative. Just using the power rule in reverse. 16y minus 8y cubed over 3 plus y fifth over 5. So it's going to be a bit messy when the fractions come in. We're going to plug into 2 and get a 32 minus 8 times 8 over 3 plus a 32 over 5. Okay, so that's a 64 over 3 and 32 over 5 and a 32. maybe we could have put these two together here, 32 and 32 over 5, by factoring out a 32. Let's just go with this and make everything over 15. So we have to multiply 32 times 15. Without a calculator. So we have 160 and a 32. We have 480. We have to multiply 64 times 5. We're going to have 320. And we have to multiply 32 times 3. That's going to be 96. 480 take away 120 is 160. 160 add on the 96 is 256. If you double 256, you get 512. The final answer to this question is 512 pi over 15. That's the volume, and the units will be cubed.